equation of mass, it says that the total mass of the particles before a reaction is going to be equal to the total mass of everything after a reaction. So it makes perfect sense. If you have a chemical reaction, we can't make matter. So we can't increase the mass of the stuff we've got or decrease. The atoms don't disappear, all right? The mass doesn't disappear. What you start with is what you end with. It's just the combinations of stuff that changes, which means that the mass before a reaction is going to be equal to that of what happens after a reaction. So during a chemical reaction or a physical change, the sum of the masses of the reactants is equal to the sum of the mass of the products. What that means is that the atoms in the reactants is equal to the atoms in the products. And it means that the number of atoms in the reactants is equal to the number of atoms in the products. It means that the mass before is equal to the mass after. Okay? So if we consider the following balanced chemical equation, let's have a look. So the chemical equation is SO2 plus O2 gives us SO3. And to balance that equation, we have a 2, we have a 1, and we have a 2. Okay? Now I want you to turn to the periodic table in the front of your textbook. Or the back, I know where it is. Have a look at your... You found it? Have you got it? Alright. I want you to go to sulfur. Do you see that sulfur has a number that says 32? You see it? So that's represented by this 32 over here. What page are we on? Kieran's a bit lost. What page, Jessica? The page before what? Okay, you got it. So 32. Then oxygen is how much? How much is oxygen?
16.
16. So I want you to have a look at the board for a second. We have SO2, but there are 2 of them. You see the 2 in the front? So I'm taking the 2 outside of the bracket. Yes? Because everything that's on the other side of the 2 is multiplied by 2. Yes? So 2 in the bracket, the 32 for the sulfur, the 16 for the one oxygen, and the 16 for the other oxygen. Because you know that, technically speaking, SO2 is made up of, if I look at SO2, it's made up of 1 sulfur and 2 oxygens. Alright? Okay? Which is where the 16 and the 16 comes from. Then, for O2, O2 is made up of 1 oxygen and another oxygen. Do you see it? Yes? And then as a product, we have SO3, but 2 of them, so there's the 2 in the front, 32 for the sulfur, 16 for the one, 16 for the other, 16 for the third oxygen involved. Before the arrow, the total mass works out to be 160 if we add it together. After the arrow, if we add up the mass, we get 160. Why? Because mass is conserved. The mass does not disappear. Are you okay with that, guys? Do you have a question, Erman? What's your question?
No, ma'am, I'm just trying to figure it out.
Right.
Okay, ma'am.
We're going to check. We're going to try another one in a second. Can you pause me, please? So if I want to balance the equations for the production of ammonia, I'm using N2 and H2, and the reason why they're N2 and H2 as reactants are because of the fact that they are diatomic, and I can do nothing about that. I start with 2 nitrogens, but I only finish with 1 nitrogen, which means the first thing that I'm going to do is I'm going to put a 2 in front of the ammonia. Yes? That 2 affects the nitrogen, but it also affects the hydrogen. Do you see that? So it tells me that on this side I have 2 nitrogens because of the 2 in front, but I also have how many hydrogens now, guys? 6. I have 6. And the reason for that is because technically speaking, this illustrates that I have one of these and another one of these. Yes? So that's what the 2 in front tells me, that I've got 2 separate molecules of ammonia. So 2 hydrogens and 1, 2, 3, 4, 5, 6 hydrogen atoms. Makes sense? In order to balance that, I need to look at the reactants again, because now it means that my nitrogens are absolutely fine, but I've now got way too many hydrogens on the product side. Agreed? I started with 2 hydrogens. I cannot possibly end with 6. They have to come from somewhere, which means what I'm going to do is I'm going to put the 3 in front of the hydrogen there, which then gives me 6 hydrogens to start with. And then this equation is balanced. Okay? So it's quite a systematic thing of comparing the reactants with the products. Are we okay? Now, I want to balance this in terms of my law of conservation of mass. So you need to give me the values from your textbook. As far as I know, nitrogen is 14. Yes? Yes? So nitrogen is 14, which means I'm going to say I have 14 plus 14 because they're 2 nitrogens. Agreed? Yes. And then I have 3 hydrogens. Now, 3 of those, which means that that's going to be 1 plus 1. Do you agree? Because each hydrogen is a 1. Yes. Confirm? On the other side of the arrow, what do I have? I have 2 times by 14 plus 3. Is it okay that I put the 3 instead of 1 plus 1 plus 1? Yes. Is that fine? So on this side, how much do I have in total? 28 plus, how much is that? 6. How much is that? 34. And on this side? 34. Can you see that the mass of the reactants is the same as the mass of the products? So there's this balancing act, both in terms of mass as well as in terms of number of atoms. Are we okay with that, proteins? Good stuff. Now, let's have a look. Let's take a step backwards and talk about balancing chemical equations for a minute. Okay. When we were writing and balancing chemical equations, we had to write down the formula for a substance first. Can anybody remember where we wrote formula? Where did formula writing come from? When we were writing formula, guys? What did we use? Do you remember? We must have written formula, didn't we? No. I'm just going to say no. Let's look at the example that's on the board here that talks about magnesium chloride. You okay? So let's look at the example that talks about magnesium chloride or MgCl2. If I want to write the formula for magnesium chloride, I'm going to find magnesium on my periodic table. Yes? What group is it in? Group 2. What is the valency for group 2 elements? 2 plus. Magnesium 2 plus. What's the other thing that we see when we talk about magnesium chloride? What's the other part of it? What's the other part of it? Magnesium, chlorine. Don't you agree? Chlorine. What group is chlorine in? Group 7, which means the valency is? 1 minus. Okay. What's the rule? What do I do now? Swappy the numbers. There we go. If all else fails, that's all I've taught you. Swappy the numbers. Okay. And then we end up with MgCl2. Do you remember this from formula writing? Yes. Yes. Okay. Let's do one for aluminium oxide quickly. So for aluminium oxide, I'm going to have the aluminium as 3 plus and the oxygen as 2 minus. Yes? Which means when I swappy the numbers, what am I going to get? Aluminium and oxide. 3, 2. Yes? Numbers swapped. Are we okay? I'm going to pause there for a moment.